Alright, so we are going to talk about day 4, parallelograms. And today we're just going to talk about proving that opposite angles and parallelograms are congruent. A parallelogram is a quadrilateral. It has 4 sides. Oops. And it looks something like this. Hold on, let me get that together. Looks a lot like that. Something similar to this. It looks a little better. And it has 4 sides, and we're going to just discuss today opposite angles, and we're going to prove that they are congruent. We're going to talk about how we can use the transversals to help us prove that, alternate interior angles, and corresponding angles. So let's talk about these properties. A parallelogram has 2 pairs of opposite sides that are congruent. The parallelogram also has 2 pairs of opposite angles that are congruent. Oops, sorry guys. Angles that are congruent. The diagonals bisect, and it has 2 pairs of parallel lines or sides. Okay, the rectangle has all of the same properties. So you have 2 pairs of opposite sides that are parallel. And you have 2 pairs of opposite sides that are congruent. You also have two pair of opposite angles that are congruent, and the diagonals are congruent. And one more extra property is it has 4 right angles. So in other words, a rectangle can be a parallelogram, but a parallelogram cannot be a rectangle. And that's because the parallelogram is missing the right angles. So here are all your properties. So you've seen these shapes before in middle school. And here are the properties that we want to focus on. So what I want you to do is to go ahead and fill in your blanks by using the information that I just gave you. And now let's go to this proof. It says if the following is a parallelogram, prove that the measure of angle D is congruent to the measure of angle B. So I need to prove that this angle is the same as this angle. Alright, so in order for me to come up with a proof, I'm going to get a plan first. And I already know this is a parallelogram. So what I do know then is that this side is the same as this side. And I know that this AB is parallel to DC. And I know this side is the same as this side. Now there are several ways you can approach this. You can draw an auxiliary line in here, which I already gave you the proof of that. So I'm going to show you another way to do this. I am going to extend this line right here. Let me get the extender. I'm going to extend this line, this one here. As a matter of fact, I'm going to extend all of these lines. So that I can show you what properties you can use to help you figure this out. Grab one more. Alright, so I extended all of these lines. So if you look here, then this red line is a transversal to the purple line. This red line DC is a transversal to line AD, to the purple line. So what I do know that this angle here, this angle 1, is the same as this angle 1 down here because of alternate interior angles. And now I can go and look, and this purple line is the same as is a transversal to the two red lines. So this angle here is the same as this angle over here because of corresponding angles. And because these are alternate interior angles, then you can see that this one up here is the same as this one down here. So I just proved that opposite angles are congruent. And then I can go about and do the same thing for these angles in the inside here. So the plan of what I'm going to say is the measure of angle ADC is going to be congruent to the measure of angle DAB by corresponding angles, because that's a transversal. And I can say the measure of angle ABC is also congruent to the angle DAB by alternate interior angles. Okay, so now we can say that the angle ADC is congruent to the angle ABC. So now I can say the measure of angle ADC is congruent to the measure of angle ABC, and by substitution. And we're finished. And now you can go and write your 2-column proof. So in your 2-column proof, you can go and you can say on this side you have your statement, and I'm going to write this in black, and I'm going to just pull it from my plan. This side I have my statement, and the other side I have the reason. So what you can do first is write that ADBC is a parallelogram. And the reason for us saying that, because that's given to us. And then we're going to run with our plan from there. That's all we were given. And so now we can say that the measure of ADC, and we're just going to write our plan in, is congruent to the measure of angle DAB by reasoning of corresponding angles. And given that it told us it was a parallelogram, we're already making the assumption that whoever reads this understand those rules. And then the measure of A, B, C is congruent to the measure of angle DAB, and that's alternate interior angles. And so now to get to the point they wanted us to get to, we can say the measure of angle ADC is congruent to the measure of angle ABC, and that's by substitution. And you finish. And you got your proof. So you come up with your plan, and then from your plan, you get your proof going. And you're done. Alright, so what I want you to do is to go ahead and try this one out. And then I'll see you guys on the next go around.